Hi everybody, and welcome to lesson 4.6, Air Pollution. The content in this video is aligned to the 3rd edition of Environmental Science for AP and is aligned to CED units 7.1 through 7.8. Here is our content objective for this lesson. Human activities have physical, chemical, and biological consequences for the atmosphere. At the end of this lesson, you should be able to identify the sources and effects of air pollution, explain the causes and effects of photochemical smog and methods to reduce it, describe thermal inversion and its relationship with pollution, describe natural sources of carbon dioxide and particulates, identify indoor air pollutants, describe the effect of indoor air pollutants, compare indoor and outdoor pollutants, explain how pollutants can be reduced at the source, describe acid deposition, describe the effects of acid deposition on the environment, and describe human activities that result in noise pollution and its effects. All of this leads us to answering our guiding question. How should we manage air pollution? Before we begin talking in detail about air pollution, we need to ensure that we are working from common terminology. Air pollution can be discussed in one of 4 ways, based on the categorization of the pollutant by traceability of origin, type of origin, lifespan, and reactivity. Let's look at each of these in turn. Traceability follows whether or not we can identify specifically where that pollutant came from. There are 2 descriptions for traceability, point and non-point. Point sources are ones such as factory smokestacks or wastewater pipes that we can identify as the origin of a pollutant. In other words, we can trace back the pollutant to a specific place. Non-point sources are things such as car exhaust and agricultural runoff that we cannot identify the actual origin of the pollutant. In other words, we can't trace a specific pollutant back to a specific car or a specific farm. Type of origin tells us about what kind of area the pollutant might have arisen from. These are divided into 4 subcategories: agricultural, industrial, urban domestic, and natural. Understanding where the pollutant is originating can provide new methods of looking at solutions to the problem of pollution. Additionally, it is important for us to know whether the pollutant is anthropogenic or natural, which can provide additional information in solving the issue. Lifespan, also known as persistence, tells us about how likely it is that the pollutant will break down in a natural environment. Pollutants are categorized as being persistent, degradable, and non-persistent. Let's look at those in more detail. A persistent pollutant, like heavy metals such as arsenic or lead, are ones that do not break down in the natural environment and often accumulate together. Degradable pollutants are those that can be broken down over time in the natural world, most often through exposure to the elements through photodegradation or weathering. There is a specific kind of degradable pollutant known as a biodegradable pollutant, which are broken down by the metabolic processes of a living organism. Examples of biodegradable pollutants are sewage, food waste, and untreated paper products. Lastly, there are non-persistent pollutants. These are the ones that degrade in the natural environment very quickly. The difference between degradable and non-persistent pollutants is the amount of time that is required to remove it from the ecosystem. Lastly, we can look at pollutants in terms of reactivity. Primary pollutants are pollutants that come directly from the source. They are considered reactive if they undergo some kind of naturally catalyzed reaction to form a different compound that is also considered a pollutant. This different compound is known as a secondary pollutant. While this diagram focuses largely on aquatic pollution, it provides a good way to visualize point and non-point sources. Here, the runoff from the suburbs and the cropland are considered non-point sources. This is a good time to say that a particular location can produce more than one kind of pollutant. For example, the factory is producing point source pollution both aquatically and atmospherically. You can see this from the smokestack. Atmospheric pollution can also be explored by looking at the overall categories of emissions. We look at these in terms of anthropogenic and natural sources. Natural sources of atmospheric pollution come from volcanic eruptions and burning wildfires. These add particulate matter, carbon dioxide, nitrogen oxides, and sulfur oxides into the atmosphere. However, all things being equal, these provide for a very small percentage of the overall pollutants in our atmosphere. The vast majority of these pollutants come from anthropogenic sources, which are looked at in terms of being mobile, stationary, or area. Mobile sources are by far the biggest contributor and include any transportation that uses fossil fuels in some form, such as planes, trains, trucks, cars, motorcycles, and even boats. Stationary sources are things like factories that remain in one place but are generally easily traceable. Area sources are those that cover a large portion of land and make it difficult to trace. These tend to be farms or urban areas. This chart discusses the major air pollutants that are considered criteria pollutants. A criteria pollutant is one that is classified by the Environmental Protection Agency as being of special consideration and that they must have specific acceptable concentrations indicated under the Clean Air Act of 1970. Let's take a look at these in detail. Note that while many of these come from natural sources, we are specifically focusing on the human-derived sources of these compounds. The 6 criteria pollutants are sulfur dioxide, nitrogen oxides, carbon monoxide, particulate matter, lead, and ozone. Note that the majority of these come from combustion, complete or incomplete, of fossil fuels in some way or form. Both sulfur and nitrogen oxides come from the combustion of hydrocarbons that have sulfur and nitrogen impurities. Nitrogen oxides, sometimes referred to as NOx or NOx, also come from the burning of biomass. Let's look at these final 3 in more detail. Particulate matter, often indicated as the letters PM with a subscript number, are fine particles that are produced through a variety of processes. The 2 that are of specific concern to us are PM10 and PM2.5. These numbers indicate the diameter in micrometer of the particulate. The smaller the particulate, the easier it is for it to get into the lungs and cause damage. Next, we have lead. In the early days of automobile transportation, lead was added to gasoline to reduce engine noise and to make the fuel more efficient in safeguarding the valves and components of the engine. The problem came when the lead was not removed in the process of combustion and was released into the atmosphere. It was also used in paint for a long period of time, which entered the air as paint degraded over time. Lastly, we have ozone. It is vital to note that this ozone is found in the troposphere, the area of the atmosphere closest to the surface of the Earth. This type of ozone is a pollutant and causes damage to multiple components of air quality. Remember that stratospheric ozone is good. Tropospheric ozone is bad. This chart shows some other pollutants that are of concern, but do not require identified acceptable limits from the EPA. Volatile organic compounds, also known as VOCs, are compounds that are aromatic that evaporate in the atmosphere, such as solvents, paints, or fuels. These often have a very distinct smell and can cause headaches. Mercury can be found as impurities in coal, oil, and gold mining. Lastly, we have carbon dioxide, which we know comes from the combustion of fossil fuels and the burning of biomass. We will discuss the problems associated with different pollutants in a little while. Now that we know which pollutants are important, let's look at how primary pollutants can become secondary pollutants. Most often, these reactions are catalyzed by sunlight. They occur when 2 or more of the primary pollutants interact, catalyzed by sunlight, and produce a secondary pollutant. The most important secondary pollutants that we will address is ozone, which here we mean as tropospheric ozone. Additionally, HNO3 and H2SO4, nitric and sulfuric acids, are produced, both of which are components of acid rain and acid deposition. An additional issue associated with air pollution is what we know of as photochemical smog. This is associated with tropospheric ozone and is particularly problematic in areas with high concentrations of automobiles. Let's discuss how it works, then we'll see what it looks like. As a reminder, stratospheric ozone is good. It is produced and naturally degraded in the atmosphere. This is a good thing. We need this. Tropospheric ozone, on the other hand, is produced as a secondary product of nitrogen oxides in the interaction with oxygen. A byproduct of that reaction is nitrogen oxide and VOCs, which produces something known as a photochemical oxidant. These oxidants combine with tropospheric ozone to produce photochemical smog. All of these reactions are catalyzed by sunlight. The important reaction for you to know is the one at the very bottom, where NOx plus O2 plus VOCs, catalyzed by sunlight, produce photochemical smog. Here are some examples of what photochemical smog looks like in 3 different areas. As you can see, these 3 cities have a thick, almost brownish haze over them. This haze is photochemical smog. Remember that the requirements for this type of smog are NOx, VOCs, and tropospheric ozone, all of which are produced in large amounts from the components released from automobile exhaust. Cities that have a high density of automobile use and large amounts of direct sunlight are likely to have photochemical smog. Additionally, notice the diagram of the most polluted cities. All of them are some of the most densely populated cities globally. 7 out of 8 of them are found very close to the equator. In our discussion of urban development and its impacts, we talked about thermal inversions. This occurs when the normal decrease in temperature at increasing altitudes is disturbed, leading to an area of warm air near ground level. This warm air traps pollutants in the cool air beneath it, making it more likely that individuals may experience negative effects of the pollutants. Beyond chemical pollution, there are 2 types of air pollution that most people do not think of as damaging: noise and light pollution. Noise pollution occurs when one is exposed to high decibels for a long period of time. High decibels are identified as anything above 70 decibels. Sounds between 70 and 90 are those like traffic. Above 90, you have live concerts, jackhammers, and plane engines. Long-term exposure to high decibel noise can lead to persistent ringing in the ears, headaches, nausea, and even deafness. Light pollution occurs when the natural sky is blocked out through the use of artificial lights, most often in urban areas. Light pollution can sometimes lead to headaches and disturbed sleep cycles. To this point, we've discussed outdoor pollutants. Let's now move to looking at indoor air pollutants. While some of these compounds are similar, there are a good number of them that are found almost exclusively in an indoor environment. Make note that indoor air pollutants are more concentrated than outdoor and are more often the cause of lung diseases than outdoor ones. Let's discuss some of the most common ones. Dust, animal hair, animal dander, and dust mites are the most commonly occurring indoor air pollutants. These are produced through the sloughing off of human skin, pets, and microorganisms that live on dead skin. Additionally, mold and mildew often occur in bathrooms and other damp areas. Most likely, these are going to cause allergic reactions. VOCs, or volatile organic compounds, are often found in basements, attics, and garages. These include paint, cleaning supplies, gasoline, and other solvents. These are compounds that vaporize easily and have a distinct smell or odor. Common ones found in the home are ammonia, nail polish remover, and cleaning products. More often than not, exposure to these can lead to headaches and nausea. Other commonly occurring pollutants are cigarette smoke, particulate matter, a variety of gases such as carbon dioxide and carbon monoxide. Carbon monoxide and particulate matter are additionally problematic when there is an attached garage associated with the home. Older homes are likely to have issues with lead. This comes from old pipes or paint. It's far more rare in newer homes and newer buildings. Additionally, older homes and buildings may have asbestos, which was once used as an insulator in walls. Exposure to asbestos can lead to the lung cancer mesothelioma or the lung condition asbestosis, where the tissue in the lung becomes almost crystallized through the inhaled asbestos fibers. Lastly, some homes may have to deal with radon gas. Radon is produced from the radioactive decay of elements such as uranium and thorium in soil and bedrock. The gas moves up through cracks in the foundations and may make its way into the building. Exposure to radon gas can lead to lung cancer and other health concerns. Remember, indoor air pollutants are more likely to cause health problems because they are more concentrated and we are in more contact with them in confined spaces. A common phenomenon that occurs is called sick building syndrome, which is a set of connected symptoms that occur due to exposure to indoor air pollutants. The symptoms occur in buildings that are either very new or very old. They often have poor ventilation and has a combination of new manufactured carpets and prefabricated furniture that are treated with preservatives like formaldehyde or other aromatics. You may be familiar with these as that distinctive new car smell. The symptoms of sick building syndrome are usually nausea, headaches, dizziness, blurry vision, and a potential skin allergic reaction when in direct contact with particular components. The hallmark of sick building syndrome is that the symptoms disappear after leaving the building. One of the byproducts of air pollution is what is known as acid deposition. This occurs when acidic compounds from the atmosphere reach the surface of the earth. Deposition occurs in wet and dry forms. Wet deposition occurs through acid rain, which is made up of sulfuric and nitric acid. Rain is considered acidic if its pH drops below 7, with increasing acidity as that value moves lower. One of the major contributors to acid rain deposition is exhaust from factories and vehicles. Dry deposition occurs in much the same way, except the compounds are reaching the surface as aerosols, particulates, and gas condensation. Lastly, we need to discuss the legislation that exists to manage and deal with air pollution. There are two pieces of legislation that you'll need to know: the Clean Air Act and the Corporate Average Fuel Economy, also known as CAS standards. Let's look at each of these in turn. The Clean Air Act was passed in 1970 to deal with the heavy pollution associated with increased use of automobiles and industry. As we mentioned earlier, the Clean Air Act sets concentration standards for 6 criteria pollutants. The law applies largely to industry, transportation, and manufacturing. Two of the most common things measured and regulated by the Clean Air Act are nitrogen, sulfur, and carbon dioxide. The majority of these are released through transportation. All new engines have what is known as a catalytic converter, which is designed to reduce nitrogen and carbon dioxide emissions. It was the introduction of the catalytic converter that was one of the major driving forces of using unleaded gasoline, as the components in the catalytic converter could not be exposed to lead. Particulate matter, such as ash, can be reduced using a wet scrubber. Dirty air is passed through a series of water-filled components where the particulate matter settles out into a liquid that can be stored elsewhere. Some factories have these wet scrubbers attached to their smokestacks. Others may have carbon capture and storage systems, which are designed to reduce the amount of carbon dioxide that enters the atmosphere. The CAF standards are regulations put in place to reduce the use of fossil fuels for transportation by setting a minimum efficiency rating for cars and trucks. The current legislation requires light transportation vehicles sold in the U.S. to have a fuel economy of at least 27 miles per gallon. The Obama administration proposed raising that to 32 miles per gallon and increasing the restrictions applicable to larger transportation, as the current law does not apply to vehicles that have a gross weight rating of 10,000 pounds or more. The following slide provides you with an opportunity to see how some of these ideas are connected together. Feel free to pause the video and explore the connections between these topics. Then, use the statements at the beginning to review.